Victoria Slack channel. Testing. Nice. All right. Yo, what's up? We'll be starting in a minute, just as soon as Victoria. If Victoria can let me know if the audio and the video is going through, and then we'll get started. Hello. Nice. Awesome. Welcome. What? It's like, what week is this? It's like week 2? Sorry, you're like almost done the program. That's great. You're pretty far away from it, but we'll make it. We'll make it together. Now, every time, because I haven't lectured for your cohort before yet, every time I start a new cohort, I try to play around with the different personality, but I forgot to come up with one this time. So you might be getting the genuine me, or are you? At the end of every cohort, I pull my face off, kind of like Jack and Hagar. Yeah. No. So my name is Mr. Boscarino. You can call me Mr. B. I don't get why the laughter. That's very serious. No, my name's Nima. My last name is Boscarino. I wasn't here for your introductions to the staff. I am part of the staff. Hello, my name is Nima Boscarino. I'm the lead instructor for the Web Dev Bootcamp. What else? I'll tell you a little bit about me. I like embroidery. I like making pies. My background's in computer science and education, and a quirky fact about me is back in high school, before binge watching on Netflix was a thing, there wasn't Netflix yet, I downloaded legally Seinfeld, every single episode of every season of Seinfeld. And I spent the summer watching it, thinking that somehow I would reach some state of cultural enlightenment. Didn't work. Really just alienated myself from my friends. So quirky fact, haha. It was the summer of Nima. Yeah, I mean honestly, just the dog days of summer. But yeah, so you'll be seeing quite a bit of me. I do a lot of the lectures, I mentor, and I'm usually, Victoria, you can't really walk up to my desk, but I sit over there. Feel free to Slack me anytime. But you're going to see quite a bit of me. Most of what I do is stand in front of here and yell at you about things for a while. Specifically, I'm going to yell at you about the date. What day is it? It's the 24th, September 24th. It's what week is it? Week 2, what day? It's week 2, day 2, too fast to code. We're about to hop into, honestly, some pretty wacky stuff. So I have a general idea of what I want to do today. I'm pretty prepared in general, but I kind of want to go off the rails a little bit, depending on what you're kind of interested in learning about. I will actually ask you, what is today's topic? Async programming, right? Or async control flow, right? That's what we're going to be working with today. And this actually is going to be pretty neat because I'll be introducing some new concepts, and I'll also be playing around with some old concepts. This is the Matrix Reloaded of lectures. There's some stuff in here where you're like, I've seen this before. So there's stuff where you're like, whoa, that's a cool new concept. And there's other stuff where you're like, I'm not sure. So we're really gonna explore a couple different things here. I'll have you know, right off the bat, a big part of my lecture style is very much about letting you kind of like give input. So I will often just, I go by the Dora the Explorer school of pedagogy. Or I might point something out and just wait for you to say it. So, yeah, exactly. Where's the map? So that's what we'll be working with. So, I don't know. Let me make a couple notes here of stuff that I kind of want to cover. I want to cover how do we deal with code that takes a while? All right, how do we deal with code that takes a while? Computers, very fast, amazingly fast even. Check this out. Hop into Node. Real quick, what do we call like the thing that I just did right now? It's the REPL. What does REPL stand for? Ooh. Yeah, yeah, pretty close. I mean, it could be. REPL officially stands for read, evaluate, print, and loop. Most kind of scripting languages are going to have, all right, I'm getting a call from, nope. Most scripting languages are going to have some version of a REPL, being a place where I can write a line of code at a time, right, and see what happens. It'll read, it'll evaluate what that line of code does, then it'll print it. And that's pretty important because the REPL is always going to show you what your code does. And then it'll loop, meaning it'll go back to reading, evaluating, printing, reading, evaluating, printing, reading, evaluating, printing. So I'm in our REPL here, Node. I'm going to do something amazing. 1 + 1. Oh my God, it's alive. It knows the numbers. Like, all right, fine. Maybe I can do 1 + 1 pretty simply. What's the point of this? All right, 5 times 9. A little bit tougher. Gets the juices flowing a bit. We'll crank it up just a teeny bit. So whatever that number times this number is, it's like, all right, I'm sold. Computers, all right, take my job, fine. Years as an apprentice of the arts of the abacus, and all that thrown away. So apparently, computers can do a little bit of math for us, which is nice. One of the other things that I can do with Node is make myself a little script. So I'm going to make myself a script and call this super.js. Super just because this is going to be a very super cool script. And I'm going to throw in some console logs. Right. Throw in some console logs. Here's a heyo. I always test to make sure that I'm running this stuff properly. So I have to leave the REPL. How do I leave the REPL? Is it exit? Nope. Is it Q? No. You're going to find that, like, I mean, I know what it is, but you're going to find that, like, lots of different REPLs have different commands for how to exit them. You'll just have to either remember them or go look them up, right? So here I might go look up, how do I leave Node? I know that Control-D works, so I'll do that. Here's a fun program, a program that's particularly fun to get out of. Have you all seen Vim yet? Cool. Here's Vim. VI improved. Right? Vim is a text editor. You can try writing text in the text editor of Vim. Hello world. OK, I got world out. OK. All right, I'm happy with world. Let's just save. Command S. Oh no. Oh, Control S. That's not it. How do I quit? Help. Get me out. So there's a specific way to get out of Vim. This is not a lecture about Vim, but if you look at the bottom here, it'll tell you what mode you're in. So at any point, if you press escape a couple times at least, like I just mash it. Eventually, any words that are down here will go away most of the time. And then when you're blank, you could go colon. So shift colon. No. Unknown Mark. You know what's funny is I have no friends named Mark. So this is very true. We'll just escape a couple times. There you go. Who knows? And then I've got myself to the colon. And then W, Q. W is going to mean write. Q is going to mean quit. I just want to quit. and then I really want to quit, so I'll go quit exclamation mark, which means quit without saving any of my changes. Intuitive, right? Anyone can be a programmer. Really, what I'm trying to show you here is that like there are many things as a programmer that like you can kind of shy away from. There are some people who will tell you that like, oh man, true programmers, they program in Vim. Not at all true. If anyone ever tells you that, you just laugh and walk away. Get out of my house. That's not true. Same kind of thing here. It's like we're going to be looking at some extra special code, and I will be very honest in the fact that there are some parts of like the things that I'm going to show you today that I really do want you to understand, and then there's other things that I'm going to show you today that are stretch, right? They're just kind of cool. They're me like doing kick flips and stuff, and half pipe, whatever. And you're like, whoa, I didn't know people could do that. One day you can. So just to set expectations, I'm going to show you a bunch of stuff, right? And at the end of the lecture, we're going to review what I've gone through. I'm going to tell you what things you should focus on and what things you can kind of just go like, OK, that was neat. Maybe I'll take a look at it when I have some time. So I'm going to start over here in super.js, right? I did this console log woo. I wanted to test that it worked. So I ran node super.js. I got heyo out. We're in business. All right. I make myself a for loop. Classic for loop. For, and let's say I want this to run 10 times. What do? I want to make a loop that just loops 10 times. Cool. So I declare my iterator. I might say something like I equals 0. And while I is less than 10, I say keep increasing I after every loop. And then in here, I might throw something like a console.log whoop. And I just want to see if this works. So I'm going to go node super.js. And I got likely 10 whoops, which is good. OK, we're going to bump this up. 10 loops, that's nothing. We know computers are beasts. Let's crank out 100. Yeah, these things are free. What? Look at that. You want more? Throw an extra 0 on there. Woo! Look at that. Anyone can have a loop. You want more? Let's put some 9s on there. Yeah. Woo! We'll run this a bit more. And what am I noticing here? It takes some time, right? This takes some time. We go whoop, whoop, whoop. And then at the end of it, I might want to say, OK, well, whoop a whole bunch, and then go, I don't know, something like whoo, because it was quite a bit of whooping. I'm just going to throw an emoji in there. Whoops. Where'd you go? A little sweat emoji. We'll do this one right here. No, I like this one personally. That one right there. All right. Whew. So I want to whoop however many number times, and then after, oh, this is still going. So I might lower the number of whoops just by a factor 10. Then we'll run this now. And this will eventually, and we could just sit here and just kind of chat for a little while. It will eventually print out the little sweaty face. There you go. Whew. Really making that computer work. Yeah. How long would it take if I what? That's a great question. Whoa, that's, yeah. So for Victoria, the question here was, how long would it take if I wasn't printing the results to the console? So in fact, yeah, let me just take out this console log, right? Just completely take out the console log. And when I run this now, quite a bit faster. Quite a bit faster. And right there we're seeing, maybe printing things to the console log is a slow operation and it takes some time. So here I'm saying for however many, what is this, 1,000,000 times, don't do anything. So that happens pretty quickly. But if I say 1,000,000 times, print to the screen, Node needs to talk to the screen and go, hello, I would like to print something to the screen. And the screen goes, hi, would you like to print something to the screen? And Node says, yes, I would like to print something to the screen. This is what I would like to print. 1,000,000 times, right? So we're going to really have to start thinking about how, like, I mean, this is a pretty banal example, but it's not very often that you're going to write a loop that goes 1,000,000 times just from 0 to 1,000,000. But I'm trying to contrive like a little bit of an example that might pop up in bigger programs, right? We're going to take some time today like to really put ourselves in the shoes of the computer in sort of like an empathetic sense, right? Like to be real real good programmers care about their machines. They go like, shh, shh, Seabiscuit, shh, it's okay, right? So we don't ask them to do too much, and when we do, we think about the work that they have to kind of go through. So I'm going to think a little bit about maybe a couple different things here. Like, for example, say this isn't whoops, but this is more of like cakes. Right? This is a bakery, and I'm making people. Wow, my emojis are not working today. I'm making people bake cakes. All right, 1,000,000 cakes, get to work. And then I also want to bake a bunch of, I don't know, I guess bread? A bunch of breads. Right? I want to make 1,000,000 cakes and 1,000,000 breads. And right now I only have one person doing this stuff. And I run this, and I get cake, 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 cake. Eventually, I'm going to start seeing the breads come in. And because code in JavaScript runs sequentially. So I got all my cakes, and now bread. And eventually, my poor little baker is going to go, whew, I made the cakes and I made the bread. Now, one of the things here, and I'm going to start using kind of like food or like restaurant examples a lot, because I'm going to find that this works well as an analogy, is when you're making a cake or when you're making some bread, right? There's steps you go through that do have to happen in order. Right? I got to make the dough for the bread, and I got to knead it, whatever, when the moon hits your eye, and then you like put it in the oven. And what can I immediately start doing as soon as I've put like an unbaked loaf of dough in the oven? I can do other stuff. So I don't just sit there and I go like, yes, my loaf of bread, and then I wait, what, an hour? How long? Bread, okay, maybe not an hour, but it bakes for a while. Right? I don't just sit there and wait for the bread. I can go and prepare other bread. Or I can go do other things. And in the same way that you will get annoyed in real life if you have to wait for each loaf of bread to continue to like finish before you do the next one. Your machines, they get annoyed at that as well. Or rather, we can use them in ways that don't block. Right? 'Cause that's a word that I'm going to use. I'm going to say that some operations are blocking. Right? Or blocking means that I have to stop, right? And I have to wait until this operation finishes, and I can't do anything else. Right? Many times that makes sense. Right? Many times that makes sense because I might do something like, we're not really going to run this code, but I might do something like, I'm trying to get a number like woo times woo, right? Big number, and then I want to console.log that number. And it's totally fine for me to wait for this to happen before I console log it, right? Because I need the number in order to print it. Right? It would be super ridiculous for you to like go, okay, here's the number, like the math, and then print it, and then Node prints out like, oh yeah, I'll get to it. Like, just a minute, and that's just what it prints out. You're like, nah, I just need the number right now. And so there's cases where this doesn't make sense to like wait. But there are other cases, or say I have number, and then I have number 2 and 3 and 4, and these are all, that's not a number. these are all like slightly different numbers. And I want to console log all these numbers, number 2, 3, and maybe 4. It can make sense for me to try to do all of these maybe at the same time. Right? If I have the ability to do all of these at the same time, right, it can make sense for me to do all of these, and then once they're done, print them out. Right? Conceptually, does that make sense? Right? I'm not talking about how the syntax is going to work. Right? I'm saying conceptually, it can make sense for me to say, OK, these calculations, let's just get them over with. Right? And instead of me waiting for this and then doing this and then doing this, if I have access to offloading this work to 4 different people, right, I can have those 4 things done and then print them out all at once. So that's going to be the main motivation for some of the stuff that we're going to do today. Okay. Cool. OK, at the moment, I know I haven't written any like actual async code, but does anyone have any questions? Cool. All right, I'm going to come at you with just something out of left field here. We're going to call this timelord.js. And this is because we're going to be playing around with just time here. Just time is flexible in your fingers. It's putty, sort of. Here's what I'm going to do. I'm going to go, here's some code. Whoop, whoop. Some code, and I want this to happen 2 seconds. 2 entire seconds. After, here comes, I don't know, that boy. There's just 2 things. I've got a console log, and then I want 2 seconds to pass, and then I want a console log, whoop, whoop. So when I run this right now, obviously, me throwing in that comment doesn't really do anything. Those both happen at the same time. Also, it looks like I perpetually have half a slice of bread. OK, cool. So here comes that boy. I want 2 seconds to pass, and then I whoop, whoop. Now, I'm going to find that if I went online, let's say I go to the internet. So here I am to the internet. Wait for 2 seconds. Wait for me. I always like seeing what gets auto-suggested. So if you go to like Google and you do things like, how do I, and then I like talk, because then you get, how do I talk to Siri? How do I talk to a live person at Groupon? How do I talk to my crush? How do I talk to a live person at Delta? So what we're going to be doing is, how do I wait for, I don't know, 2 seconds in Node? You're going to find, here's a hot tip, just PSA, like do. Hot tip as a programmer. Just ask Google questions. Genuinely just ask. Howdy, Google. How do I wait for 2 seconds in Node.js? Thank you kindly. What? How can I wait in Node.js? That's exactly what I wanted, right? Fun fact, there are other people on the internet, other programmers, and most of them tend to ask questions. So if you form your question in the form of a question, you'll likely find a Stack Overflow post written by someone just like you. Right? I have found I have more success writing stuff in the form of a question than writing stuff in like whatever kind of Google foo I think I'm trying to do. Right? Just howdy, Google. So how can I wait for Node.js? I'm going to take a look here, and I see a particular thing. I'm seeing this function called set timeout. Right? Set timeout is the easiest way for me to introduce you to asynchronous programming. And when I say easy, I don't mean this is going to be like easy to understand. I mean there's going to be the fewest like lines of code for me to show you. This is still like you're still going to have to kind of like warp your brain a little bit. So I know how the set timeout works, so I'm going to write it out for you. But if you wanted, like, you could read at the Stack Overflow post. Set timeout. Fun fact about VS Code: as soon as you start writing stuff, it'll auto-suggest how to use the thing. And this tells me, hey, set timeout works in this particular way. And if eventually, like, you'll get comfortable enough to understand or be like comfortable with the format of how they suggest stuff. The way that set timeout is going to work is that I'm going to need to say a certain amount of time to wait. We'll say 2 seconds. And where set timeout is going to be done in milliseconds. So console log, here comes that boy, then set timeout, and then whoop whoop. And I run this. I still have the bread. All right. I run this, and I got an error, an error, if you will, a fancy error. What does the error say? Callback must be a function. So error, invalid callback. No is going to be very, very dramatic most of the time. Right? If you toss even a slight little mistake in there, no is going to be like, I can't deal with this. I don't know. Right? You just got to go in and be like, all right, OK. Shh. Error, invalid callback. Callback must be a function. So here's the thing. The way that set timeout is going to work is that set timeout is going to want to take some stuff. OK. Let me get this thing out of the way. Does this syntax here confuse anyone? OK, speak now or like forever hold your peace. Right? Yeah, exactly. Right. This is an anonymous function done as an arrow function. Right. So I'm going to be using this kind of syntax a lot. Let me start off by just making myself a function. Right. Let me const whoop. I'll just interchangeably, like I will sometimes write it this way and sometimes as an arrow function, just because I like keeping you on your toes. There is no difference right now. They're the same thing. And I'm going to take the console log whoop whoop. I'm going to put it in here. This is the whoop function. Supposedly, I could call whoop like that. OK. So if I say, and this is just an experiment here. If I say the words that set timeout should accept a function or should accept a callback, right? And I know, like, we've never, at least I don't think you've ever worked with the set timeout function before. Correct? Cool. Haven't worked with it before. If I was to tell you that set timeout will run something after 2 seconds, right? How would you imagine or how would you want this syntax to look like? And so we get to invent our own syntax here, right? There's no wrong answers. But if I said that I want set timeout to run the whoop function after 2 seconds, what would you want to be able to write to do something like that? Is that a hand?
I mean, I wanted to know what I want to run and how long I want to wait.
Yeah, cool. So for Victoria, it was I wanted to know what I want to run and how long to wait. How do I give that information to the set timeout? How do I tell it, hey, this is what you should run, and this is how long you should wait? I have to give it the function, right? So set timeout is only able to do stuff when it's given information about it, right? So I need to tell it, hey, here's the whoop function, and this is how long I want you to wait, right? And apparently, supposedly, maybe, set timeout might run the whoop function after 2 seconds, right? Do I know this right now? No, because I didn't make the set timeout function. But this seems like maybe an intuitive way, right, of using the set timeout function. Right? And again, if that doesn't feel intuitive yet, right, I want you to think about the fact that we're saying, I want the whoop function to run after 2 seconds. Right? And if the set timeout function is the one that has the responsibility of doing that, the two things it needs to know are, what is the whoop function, right, and how long should I wait before I run it? Why did I write it like this and not with 2 parentheses afterwards? Because it knows. It expects a function. What happens when I do the parentheses like this? And I'm calling the function, right? I'm invoking the function. This is something that you explored, I guess, last week, right? You learned about callbacks, I think, at the end of last week. And when I teach callbacks, when I teach functions, I point out that there is a difference between there being a light switch and you turning on the lights with the light switch. Right? Say, oh, here's the light switch. Nothing happened, right? I'm just letting you know that if you wanted to, there's a light switch that you can use. Right? Whereas when you actually flick it on and off, you're invoking that thing. So here is the idea of whoop. It's not the whooping itself. It's the idea of the whoop, right? And set timeout can whoop later. I'm going to run this right now. I'm going to go node timelord.js. I'm going to see here comes that boy. 2 seconds later, I got the whoop whoop. Yeah. Cool. All right, here comes that boy. 2 seconds later, I'll just run this again. Whoop. This is great. So I know there was like, I guess, quite a bit of a jump in what I was talking about, but I'm gonna go over the same idea multiple times, and that's what all of this lecture is going to be about. Is this idea of passing a callback to something else. Now, I'm just going to make another function. This one's going to be called const heyo. And this one's going to console.log heyo. And I said I wanted, here comes that boy, then 2 seconds. Then I'm going to say, OK, you know what? We're going to wait 4 seconds. 4 seconds after this function. Or, nah, you know what? We'll just wait 1 second. Wait 1 second, and then I want to heyo again, like instead of the whoop. Wow. Yeah, audio's still working. I want to wait 1 second, and then I want to heyo. What do you think I'm going to write? Heyo, and then 3,000. Oh, clever. Clever. Where did the 3 come from? Just an extra second on top. All right, let's see. I'm going to run this right now. And I get, here comes that boy. Then whoop whoop. And then a second later, I get a heyo. Now, I, as just the person that I am, I go, what? I didn't want to wait 3 seconds. I wanted to wait 1 second. Right? I'm going to change this here and go, pff. It's going to be a 1 second wait. Right? And I'm going to run this right now, and I'm going to find something interesting. What do you imagine is going to happen? Can you say that like really loud? Heyo, yeah, it'll print heyo first. And I get, here come that boy, then heyo, and then whoop whoop. And this is immediately where, when I started coding with JavaScript, I said, I hate this. I'm leaving. This doesn't make any sense. I wrote it afterwards. I said, do this at what? And then you kind of scream a little bit. You kind of come around to the idea after a little while. What we're dealing with here is that idea of async, right? Async. Async meaning this isn't happening synchronously. Synchronously meaning one thing after another. Right? Here, it doesn't immediately seem as if things are happening one after another because I get the whoop and the heyo declared as whoop and heyo. But what gets printed out is heyo and whoop. So I'm going to highlight a couple things here. There are some calls which are synchronous, and there are some calls which are asynchronous. Asynchronous, such as the set timeout, means that when I call this, JavaScript is not going to wait. It'll keep going. JavaScript's going to keep running while whatever this function is supposed to do just does its thing. So I sort of have two things happening at the same time. Yet here again, right? And this one's going to say, keep going. Right? If there was other stuff to do, it would just keep going. Now, if I was to maybe time things with a stopwatch, And synchronous calls happen almost instantaneously. Almost instantaneously. If you remember back at the super, right, when we did the for loop, the gigantic for loop with nothing in it, it happened almost immediately. Right? So most things, most like operations, most function calls, console log is a bit different because it has to deal with something external, like a monitor. Right? Pretty much everything else is going to happen immediately. So when I look at these calls here in the time lord function, or in the time lord file, I'm going to take a look at what is actually running. What's the first line of code that runs here? Console log, here comes that boy. Right? That's the very first line of code that runs. And then almost immediately, I will declare two variables, whoop and heyo. Right? And these two variables are functions. Then, again, almost immediately, I will set a timeout. And setting a timeout is very similar to setting one of these, like cooking timers here, like setting one of these things. The turn of the thing is immediate, right? Setting it is immediate. You set it, and then you just kind of forget it, right? And then you might take another one and also set that, and as well, sort of forget it, until it kind of comes back. Right? So we're able to set as many of these timeouts as we want, or set as many of these async operations as we want, and then continue on. Right? And the idea is, hey, you know, I'm not going to whoop right now, but I will trust Node to whoop later. Right? I'm not going to heyo right now, but I will trust Node to heyo later. Right? And this is how long I want you to wait, but I'm going to continue. Okay. Now, async is one of those things where I think you get like this spiral of understanding. I found that when I was learning async, I would get really, really close, or I would feel like I have this grasp of it, and then it would just kind of like, it was dust this whole time. And I get a bit closer, and it's just another mirage. But eventually you get more and more of a grasp. And the place where you really start understanding async is probably, unfortunately, not today. Right? You're probably going to understand async and why this is a thing, right, as you start working with networking later this week, right? Late this week, I think Friday, or Thursday or Friday. Because async, or the fact that async exists in JavaScript, right, is to solve particular problems. So for us to just learn the construct and not see the problem, it is going to feel like a little just highly theoretical. Yeah. Yes. Oh, I thought that was a question there, but it was a hand. Yeah. Cool. So let's see, what time is it right now? 10:41. We're going to hop into I want to do one really funky example. Here is a file that I'm going to call sort.js. Am I? I shouldn't have done that. This is a file that I'm going to call mystery.js. Because you're not supposed to know it. Oh, I'm stuck. Mystery.js. All right. Everyone, please forget the word sort. I did not say that. So, so here is an array. It's a very interesting array. It's called numbers. Ooh. You want numbers? I got numbers. 67. Anybody got a favorite number? 14. Very nice. Anyone else? 42. Good number. I'll do 1,000. We'll throw another one in here. No, that's pretty big, actually. We'll do 345. And then my favorite number, 81. Wait, what's that? 85. Oh, nice. These are all excellent numbers. Very good. And what we're going to do here is I'm going to loop through the numbers. I'm going to go 4. And if I wanted to loop through a list of things, like what options do I have for writing my for? I could do a for of. I could do a for each. I could do a C-style loop. Poor little for in loop. No one ever remembers that, but you could do a for in. You could do a while. Wow, that's definitely. We'll do a while actually. Yeah. And we'll start off with let index equals 0, while I is less than 0. I can't remember the last time I wrote a while loop. And then I plus plus down at the bottom. Yeah, four. Yeah, exactly. While was like, I was doing the job pretty well. And then fancy 4 comes in with a bow tie and Ray-Bans and, I don't know, a bucket hat. Just, I don't even understand. So while I is less than 0, what I'm going to do is I'm going to go console log numbers I, right? Because I'm using this index. So just to really stress things. And I go node and mystery JS, and what I got is absolutely nothing. Huh? Oh, because this was supposed to not be less than 0. I was stuck in the for numbers.length. Wow, you can really tell I haven't written a while loop in a while. Sweet. It's been a while. I kind of feel like a dad who's trying to juggle a soccer ball for oh yeah, I used to, oh man, and then get kind of angry and shut the door. No dinner tonight. No. So here's a bunch of numbers just getting printed out. I'm going to replace the console log with something pretty interesting. I'm going to do a set timeout. What? I should sort these numbers? I should clean up this array, right? As soon as I see an ugly, messy array just like this, I gotta sort it. So I'm not going to do that right now, but I might do that later. What I am going to do is I'm going to write some mystery code. Here you go, function. I'm going to say console.log numbers I. And then I'm going to go numbers I here. Whew. Very weird code. Very weird. So what does this code do right now? Yeah. Might print the number and then wait, maybe. Let's see. So our hypothesis at the moment is that this code here might print the number and then wait. And which number do you think? Can you give me? Can you give me an example of what gets printed out? Yeah. Cool. Sweet. So for Victoria, the hypothesis here is that we might get 67, and then it might wait for 67 milliseconds and then print out 14, and wait for 14 milliseconds and continue. Is that's what you said?
Yeah,
or vice versa. All right. Well, let's see. I just hope this works because I kind of picked the numbers sort of randomly. All right. Undefined, undefined, undefined. What? So we got undefined, undefined, undefined. You know why this is? I think it's because, well, we could always just console.log what I is at the moment here. Let me just see. It's like 7 every time, which is weird. It's really weird. Why is it 7 every time? It's the array length, right? It is the array length. And I could even play around with this and say, okay, let's throw another number on here. Right? I'm going to see that number goes up. And it does make sense that I'm getting undefined, because if I tried to get the element at index, in this case 8, what am I going to get? Undefined. Right? Dot length minus 1. Well, I mean, I could try getting this I and then going -1, but this is starting to feel a little bit more complicated than I want it to be. What I'm expecting out of here to print out the numbers 0 through 7. Right? And it's funny because if I take this and I go console.log I out here, we're going to say, OK, this is what is outside the set timeout. Right? And the other ones are inside the set timeout. And I run this right now. And outside of the set timeout, I get 0, 1, 2, 3, 4, yada, yada, yada. But what do I notice down here? Sure, so it could be the array length. What do I notice about the way that I've written this code and the way that the code's getting printed out? Yes? There we go, right? So it is setting a timeout. This code here is setting a timeout that will run later. And it just so happens that this code runs after the loop is even finished. Right? The loop will finish, and then the set timeouts will go off. Remember, a set timeout is kind of like me setting a timer, or like one of those ding that happened. And even though I wrote this code within the loop, right, I'm no longer in the loop anymore when the set timeout triggers. Right? Or to be more explicit, I is no longer the number that I thought it was. Right? I, when the loop was running, might have been 0, then 1, then 2, then 3. But notice that at the end of all the loops, I turns into 8. Right? The very last value that I is 8. Yes? If I'd have done it as a for loop, well, let's see. Whoops. We could experiment with that. If I had done this as a for loop, like for I is less than 0, I equals 0, I is less than numbers.length. Yeah, but it's a let variable, so it's going to be OK. But I could. Oh, that's what you mean. So if I'd done this, right? So if I rewrite it this way and I take away the I++ because it's a for loop, we could explore to see what this does.
Victoria has a question.
Yep. So Alan Dodge says, while I is less than 0, so never 14, 42, 67, can you pass the function I? That's a really great question. Like, can we make it up here such that the function knows what the value of I is at that one moment? Right? That might be something good to do, like pin what the value of I is and give it to the function. Right? We could explore that. And I think we will try something very similar to that idea in just a second. That's good intuition there. I wanted to see why, like, what I got syntax wrong here. Oh, I++. Whoop. I'm going to run this. So interestingly, with the for loop, it does kind of end up figuring it out, which is fun. And I guess it does have to do with the scoping. But I'm gonna ignore this just for a second. We're gonna pretend I never did that. We're gonna go back up here, and we're gonna explore what Alan had kind of pointed out. Now, I want to be completely honest. I've never done this example with a while loop before. Right? So like I know it works with a for loop. A while loop might have to fiddle around with it before it works, or I might eventually just get frustrated and go like, no. This example here is really more of a it's more of a mind bender than an actual functional thing. I'm gonna go in here. I'm gonna say something like maybe let current equals I, and then maybe I'll try doing current instead of I in these ones here. And we'll just see what that tends to do. Like I'm saving the current value of I so that hopefully maybe it doesn't change. Yep. The while I is less than 0. Can you pass the function I? That one? Yeah. Yeah, so that's sort of what we're doing right now. Right? The idea is like we might be thinking like we want this function to remember what I is. If we just pass it, or if we just leave it like this, right, with instead of current like I, the value of I is going to change over time. Right? But I can pin down the value of I to some other variable, and I can make my function use that variable instead. Right? And I can explore to see if maybe this works. So if I run this at the moment, and that did end up doing something to that effect. So right now what you see is just a mash of numbers, right? And I know that this example doesn't make a lot of sense at the moment, right? I'm going to take away some code, and we're going to spend some time thinking about what this code does. Right? And again, I want to highlight that this example here, not a functional example. This isn't something you're going to be doing in your code. Right? This isn't something that you need to master. I'm trying to just make you uncomfortable and like think in a different way. Right? And then we're going to use that to roll into some examples in the second half of the lecture that are a bit more practical. Right? So the code that I said I'm going to get rid of is this one console log for current. And I'm going to get rid of this console log here at number 5. Right? So this here right now is the code. Right? And I have a bunch of numbers, and they're not in order. And the original hypothesis had been maybe we'll see 67, then 14, then 42, right? Each separated by like 67 milliseconds and 14 milliseconds. But what I actually end up seeing is something slightly different. What did I get? I got them sorted, right? I got them in the order of what? In numerical order, right? In ascending size, right? So 14, then 42, then 67, then 81. Right? So can anyone explain to me what is going on in this function right now? Or not this function, but rather in this code here right now. Right. Oh, Alan's typing. Yep.
So the numbers current will print out at the time of like 14 milliseconds, for example, and because it's like you said, it's a 1,000 printing out at 1 second before 3,000 was printed out, or 2,000 or whatever, it'll print the 14 first because that's at 14 milliseconds instead of 14 milliseconds after.
There we go. Excellent. That's exactly it. And the way that Alan put it out here is also the same way as, and your name was? The same way as Julia said. So for Victoria, what we're saying here is that we're setting a bunch of timeouts that will wait however many number of milliseconds. So here's a timeout that only waits 14 milliseconds. But here's another timeout that waits 67 milliseconds. Right? So just to echo what Alan said in the Victoria channel, set timeout is waiting an amount based on each number in the array. And all of these timeouts get set almost at the same time. Almost at the same time. Right? I mean, I could make these numbers slightly bigger to make it a little bit clearer. Like, this one's going to be 6.7 seconds, 1.4 seconds, 4.2 seconds. We're going to say that this is just 1, 3. This one's almost 8 seconds, or just past 8 seconds. Same and same. And what I'll see is that if I was to throw a console log in here, right, I might do something like setting the timeout for, and then the particular number, right, like numbers. So I loop through and I set the timeouts for each number. When I run this right now, what I'll see is that the set timeout for all the numbers happens almost immediately, right? They all happen at the same time, but then the timeouts trigger at different times. And does that make it a little clearer? And again, the way I encourage you to think about timeouts, right, is like setting a timer, right? Like and then you wait. And then eventually it'll ring. Eventually. So again, I said this particular example here, right, it's a bit contrived. You're not going to be writing code like this. This is more of a mind challenge. It's a puzzle. right? But and you would never ever sort stuff like this, because say that the number I wanted to sort is, we're going to be waiting a while. Get started, and we do all the first couple ones, and then by 8 seconds in, I'm like, yeah, I'm sick of this demo already. And now we wait. And we wait. So obviously we wouldn't want to write code like this. Yep.
If you change the numbers to like a range from like 0 to 1, could you sort of like you change them all to like 0 to 1?
Ooh, that's a great question. So for Victoria, the question here is, what if instead of keeping the numbers gigantic like this, like, can I change these numbers to a range from 0 to 1? So I'm assuming that you're saying the smallest number would be 0, the largest number would be 1, and all the other numbers would be gradients in between, right? That's a great question, and you're actually going to find that set timeout works a little weirdly. So I'm going to just do we'll call this one throwaway.js, and I'll just do a set timeout. This one's going to console.log a after 1 millisecond. And I'm just going to do a bunch of these that are all pretty close to each other. So that's maybe this one's 2 milliseconds and 1, and this one's 3 and 1 and 2 and 3. And I'm just going to change these. This is maybe a little bit much. Let's just do that. We'll do A, B, and C. Cool. Just an A, B, and C set to timeouts that are very close to each other. And when I run this right now, I will sometimes get ABC, but other times I will get BAC. Right? And then yet other times I might get like CAB, who knows?
There's a question from Victoria.
Yep. Can the delay be an event handler like mouse click? I love it. Yes, absolutely. And there you have touched on the whole point of asynchronous programming, is that we might be waiting for interesting events. Right? For example, when there is a click, do this thing. Right? So absolutely, yeah. Instead of having something like a set timeout, we might have something like when mouse click, right? Or when person presses a key. And that's actually what we're going to be doing in the second half of the lecture, is we're going to wait for key presses. Right? And when we'll press the keys, then we'll do stuff. Right? Is that another question there? Oh, about this, right? Yeah.
I'm just curious if it's an issue with the print again, or is it like internally is it handled properly?
So it could be an issue with like a couple different things. So the question here for Victoria is like, why are these coming out in different orders even though I run the same code? The thing is, set timeout, it'll run after an approximate amount of milliseconds, right? Like approximately that much, right? It won't be exact. So if we set 2 timeouts for very close to the same number, right, at the same time, it's not a given that like one of them is going to run before the other one, right? It's going to be sort of approximate. And does that kind of clear that up a little bit? You can't use set timeout to do like very precise things. Those are you use this mostly to be like, do it every 150 milliseconds or so, right? With like a very, very small kind of degree of error there. Yeah?
Just a random question. Do you know how many clock cycles are in milliseconds?
No, but we could kind of look that up. The question here is like, do we know how many clock cycles are in a millisecond? Like, how much stuff can happen in a millisecond? Off the top of my head, no. But we'd have to like Google that, and I'm sure there's going to be an answer for it somewhere. That's a great question, though. So I wanted to end the first half of the lecture here, right? Where what we've done is mostly theoretical, right? What we've done is mostly just kind of like bend our minds a little bit with async ideas. And we're actually going to be using these async ideas and building out a little bit of a demo in the second half, right? I again want to stress, not everything from this lecture is stuff that you have to come away with like, oh, I fully understand all this stuff. In fact, like it's my job to kind of stress you out a little bit. I also want to extend that to really all the lectures that you're going to be sitting in on, right? Is the point of lecture isn't to like tell you and like teach you exactly what you need to know, right? The thing is, like, if that was the case, then you could just like not do boot camp and just watch videos all the time, right? You're going to do most of your learning, or really honestly all of your learning, through practical stuff, right? So try to take lecture as an opportunity to just get introduced to ideas, right? And then take the things that maybe I do and try to replicate them when you have some time. Like we're always going to give you notes for the code that we write, right? And take the time after lectures and take the time during your assignments to fill in those cracks, right? And to really, really stretch. So don't, feel upset if when you finish a lecture, you're like, I still don't really understand that concept 100%. Cool? Cool. So what we're going to do is we're going to take a break. And I'm going to be pretty generous. Let's do treat yourself. We'll do a 12-minute break. Okay? I'll give you 2 extra minutes. 12-minute break, and then we'll start up again. So at 11:16 is when we'll pick up. Great. Word up. It's time. So I kind of let y'all have a little bit longer than 12 minutes. Whoops. So let me just make sure that Victoria is here. Yo. So if Victoria could give me a thumbs up or a hello, a funny joke, a quote, a hello, sweet, that works. Oh, Graham, thumbs up, nice. Oh, funny, yeah, like this. Woo. We're gonna laugh at that one. And a hi-oh, all right. So we're gonna get right back into it. I showed you at the beginning, in the first half, just kind of, again, theoretical kind of concepts behind async. And I used a bit of like a contrived example of, iron moss. No type. All right. I used a bit of like a contrived example with this set timeout thing. I'll be honest, most of the time, Right, there you go. I have very shallow pockets, so the thing kind of slips out. All right, I was gonna say, let me just be very, very clear about this. Most of the time, when you're dealing with async, it's not because of set timeout. Right? Most of the time, set timeout is not in your code. Right? Set timeout I'm using as an educational tool, right, to kind of simulate some asynchronous behavior. Right? But most of the time, you're not going to be dealing with set timeout. There's going to be other things that are asynchronous. Right? You will just find, oh, this function happens to be asynchronous. Right? And you're already going to start exploring that today. So I just really want to be clear about that, because some people think that async and set timeout go hand in hand. No, async is a thing, and set timeout happens to be an async function. Right? The thing is, I can't show you a ton of other async functions right now, because then we kind of like get into the scope of other lectures, and I'd kind of make this a little bit more confusing than it needs to be. Right? So just kind of hold on in there. So what I think I want to show you is I want to kind of play around with an idea that's very similar to, if I understood Lloyd's question from earlier, similar to that in the sense of, can our callback be attached to something like a mouse click? So I'm going to do that here with keypress.js. I want to write some code where I have a particular thing that needs to happen when you press a key. Okay? When you press a key. I'm going to say that the thing I want to happen is I want it to console log the words ouch. Right? It'll just go ouch when you press a key. And now, just blank slate. What would you imagine this code should look like? Let's just kind of sight read or improv this code. If I say, when you press the key, print ouch. Yep.
So you have a function, and it's waiting for a click to happen. And when that click happens,
OK, so I have a function that waits for a click to happen. Or I'll say like a mouse press, key press to happen, because I'm not going to be playing around with the mouse today. But when a key press happens, then run a particular action, right? So the particular action, here's the thing that should happen. Maybe it'll be const action, right? And this is going to be a function that just goes console.log ouch, right? Console.log something. And then I might have a function that waits for that key press. So this is maybe going to look something like on key press. Right? It's not actually going to be this, but I'm coming up with imaginary code. And I might want to say something like on key press, whoops, do that action. Right? Now, again, this is not real code, right? But the concept being that I pass this thing to do as a callback to this, where the key might not be being pressed right now. It might be pressed later. Right? It might be pressed many times, but I'm registering something to happen later. So I'm going to go ahead and I'm going to say, let's do this kind of idea, but as actual code. And now, bear with me. Right? I'm going to bring in some code that's not going to make a ton of sense. Right? What I'm actually going to do is I'm going to bring in some code and then immediately change it. Cool. Nope, that's not it. That's not it either. Where'd you go? There you go. Whoop. OK, so I'm going to bring in some code, and I'm going to immediately kind of change it from what you're seeing. So just, if you want to close your eyes for a second, like that's cool. And we're going to go sweet. All right, so nobody closed their eyes, apparently. Looks like I have no power here. My authority is very limited. Here's a bunch of code. We're going to work our way through this code. There is a thing called process in Node. If I was to hop right into Node, where'd you go? Right into Node, there is a thing called process. Right? So the word process gets us this thing. What is this, the thing I'm highlighting? What kind of thing is it? All the functions are available to process, but specifically as a JavaScript thing, like what is this? It's an object, right? That's really important. This is an object. So it collects exactly a bunch of functions, maybe also some just strings, right? Just a bunch of stuff in one place. One of the things inside a process is this standard in. Process.standardin. What is process.standardin? Yet another object, right? So there's a thing called process.standardin, and inside of it, inside of process.standardin, there are some functions that we can call. Right? Standardin is used to read input from the keyboard. Right? So I'm waiting for people to type or stuff like that. So this here is standardin set raw mode. It's raw. I don't know what this means. I have no idea. I have no clue. This is code that I stole from someone. Right? So we're just going to ignore this line of code. If you want, you can go online and look up what does this do? Does it matter for today's demo? Absolutely not. Right? Set encoding, UTF-8. Again, doesn't really matter. This doesn't matter either. Right? I need it to make my demo work, right? And you will be told to copy 2 lines that are either that or very similar in your assignment, right? But you don't need to understand them, right? In order to understand async. This is very specific to how does process.standardin work. Heads up, you're not going to be working with process.standardin very often. This is, again, an educational tool to get you to learn about callbacks and async a bit more. But this part here should seem pretty familiar. Standardin on data, and I go action. Right? Maybe you haven't seen exactly this code before, but this pattern might seem familiar. Right? What am I saying with this line of code? Data and action are parameters passed to whatever the on function is. Right? We can read this as saying anytime, so on data, anytime there is a data event, right? Anytime standard input receives new data, I want you to run this action. Right? Anytime there is new data, I want you to run this action. And I'm going to save this, and we're just going to run this and see what happens. So node key press. What do I notice happens right now? What's that? It's waiting, right? It hangs. It just waits. And then every time I press a key, it goes, ouch. Ouch, stop it, ouch, right? Oof. So it's code that I've attached to something, right? That's where I find a lot of fun personally in programming, is when I can attach stuff to events. Right? I like interacting with my programs, and I love the idea of like, when I press this key, turn that light on, right? Or when I click, send an email. Like, that stuff is just really fun to me, like hooking up these little listeners with event handlers. So this is very similar again to what Lloyd pointed out, an event handler like a mouse click. Like, I can say, hey, when somebody presses a key. You know what's fun though is, how do you usually leave a node program if it's hanging? Like, what do you do? Control C. Here's me doing Control C. Ouch. Ouch. It won't let me leave. This kind of reminds you of Vim. Right? No, let me out. The only way that you can kind of really leave it is quit. So you close the tab, or I've got the little kill terminal button. So I go back. Right? So I'm probably going to need something in here like, if the key is Control C, then quit, or something like that. I'm probably going to need to do that kind of stuff. Here's another fun text editor. I've shown you Vim. Does anyone know about ed or ed? So ed, let's check the manual. You can go man ed. Ed, the ed utility is a line-oriented text editor. Ooh. In fact, if you look up on the internet, ed is the standard text editor. Really, it's the only one you should be using. Right? It's the standard text editor. So let me try to use ed here. Ed, here I go. Whew. I'm in the text editor. Hello world. Nice. Oh. OK. You know what? We'll just save. Control S. No. Save. Quit. Turns out that quitting ed is a lot harder than quitting Vim. To this day, I still don't actually know how to quit ed. Because ed only has one error, and it's the question mark. And that just means something was wrong. Yeah. So yeah, to this day, I still don't know how to quit. So what I'm going to do here is, I want to, when I run this action, I might want to check to see if the key is Control C, then I want to quit. Right? How do you think I'll be able to check to see if the key was Control C? Or rather, like, what kind of code do you think I'd want to write here? If the key is Control C, what kind of JavaScript construct? If the key is Control C, think it might be a for loop. I know you're a big fan of while loops. If the key, it's an if statement. Oh my God, wow. How did you know? If the key is Control C. Now, what I want to do is quit. I'll tell you that there is a process.quit or exit. Who knows? Process.exit. Yeah, there is a, I think, .exit. Yeah, there's a process.exit function to quit your program. So that's fine. We'll just say process.exit if this condition is met. And what will I want this to maybe look like? If maybe data equals and something like Control C. Right? So I'm just going to write out right now like control plus C or whatever. It's not going to be that, but it'll be something similar. Right? And where do I get data from? And it might get passed into the function, into action. So here's the thing. A lot of the time, when you're dealing with callbacks, and this is something you've probably already started experiencing, is you lose a little bit of control. Right? There's a concept called inversion of control, right? Where you don't get to make the decisions because somebody else has made decisions. Right? This is a bit of a philosophical thing. We're using a tool where the person who made the tool said, you can use this like this, right? And they will have documented it. For example, have you all seen the for each function? Right? Array.forEach. Right? When I look at array.forEach, so say I go, if I have an array and I go dot for each, I can pass to this thing a function that may be taking an element, console.logs that element. Right? I know it's squished, but you'll get what this code does, right? So what's curious about this, though, is that like I have no way, as of this keystroke, I have no way of knowing like what the callback should be structured like. I need to go online and look this up, right? Or I need to go look at the documentation. Right? There's just no way. I don't get to decide how to structure the callback because the callback is going to be called in a specific way by the for each function. And in the exact same way here, with the on function, I don't get to decide how the action or how this callback here gets structured. Right? If I was to look at the documentation, I would find that data or something gets automatically passed in. Right? And I could go here and I could go console.log data and just see what gets passed in. Right? In fact, any number of stuff might be getting passed in. I have no idea. So one thing that I do sometimes is I just go just more stuff, and then I just see, okay, like let's see everything that's getting passed in. Maybe there's 4 things. Maybe there's 5. Who knows? And I'm going to go ahead and I'm going to console log when I run this. And I'm going to see that something comes through. Right? What came through? Every time I do this. Right? Just some stuff. Anybody see the subliminal messaging? You see it? Yeah. So Ovaltine. Yeah. So what I get is the key that got pressed, it's coming through, and then I don't really get anything else. So in JavaScript, like your function, oh right, I didn't get the quit on here yet, so quit. Your functions can take in any number of stuff, and if something's not being passed in, it'll just be undefined. Right? JavaScript's pretty forgiving. So I get this data, and I can see, okay, well, if the data is a particular thing. So for example, if my data is, and I can check to see what it is when it's Control-C. Control-C. So helpful. This is the Control-C character, not a visible character. Control-C has a specific like code. It is this here, \U0003. It's a Unicode character that stands for Control-C, or like quitting the program. So I could do something like, if the key is Control-C, and so you're going to do that here. If the key is Control-C, then I want to quit. And now what I get is, I can, oh, whoops. I said key instead of data, my bad. So I got an error because when I copy the code over, in my old file it said key, but I'm using the word data here. You can call this anything you want. You're aware of that, right? You can call this stuff anything you want, so give it a nice name. I like the name Florence. There you go, if Florence, just names. But data, in this case, or key, is probably going to make sense. So I run this. And now every time I type, stuff happens, I'm console logging the key, I print out ouch, and then if it's Control-C, then I quit. And when you see that I'm building this thing up like bit by bit by bit, right? And I didn't tell you what the full goal of this demo is going to be. I'll tell you now. We're going to build a restaurant simulator. This is like a thing where you order stuff, and I might order a burger, or I might order a burrito, and it takes a little bit of time to make each of those things. So we're going to be mixing these ideas of the key press, right, or the on data, and the set timeout, right, to make like a fully fledged kind of restaurant simulator. Are there any questions at the moment before I dive into that? Cool. So I'll write out a little bit of a description of what I want to build. So restaurant sim. Anybody ever wanted to open up a restaurant? Do you have a restaurant name or something? Oh, you got one. You got an idea. Yeah. Yeah. Big ol', oh, Terrence is writing one. Let's see, big ol' Jimbo's. Let's see what Terrence has. Oh, there's like a 10-second delay for Victoria, by the way. I don't know if y'all know.
I'll open up a coffee shop. Bianco Beans.
Bianco Beans. And then Terrence just wants a side of mayo with fries. I'll make sure that that's a side of mayo with fries. Wait, okay, so, oh, a side of mayo with your fries. I thought you wanted a side of mayo and then also fries with the mayo. I'm like, it's the other way around. Sweet, so we'll go for big ol' Jimbo's featuring Bianco Beans coffee. Right, so we'll be able to have some stuff there. Actually, any of you angel investors by any chance? In terms of, I have plenty of business ideas, so hit me up after lecture. I've got tons of ideas, and I'm just looking for the right investor.
How much funding?
Funding is negotiable with equity. Here's an idea for a restaurant. This is a restaurant where you get a discount if you share food with someone else. Meaning, when you go to a restaurant, you're like, maybe this is just me, but if I need to order something off the menu, there's like too many options. I'm like, oh, I don't know what to get. That looks really good, but that looks really good too. Like, there's people like eating the food. Sometimes, and I've thought about this, I've never done it because I still have some social skills, but like I've wanted to just walk by and just try some. Right? But this is a restaurant where if you are encouraged to share your food with strangers and you get a discount, right? So it's like a restaurant filled with people like eating food that's maybe like okay, but they're all acting like it's so much better than it really is. Like, oh, these spaghetti, so good. So then people will like want to come by and try it to get a discount. Anyways, that's my restaurant idea. Hit me up. Still on my A rounds or whatever, my Series A. So we're making a restaurant simulator. This is going to work this way. We're going to say there's like 3 different orders. One is your main. The main is going to be, what do they serve at Big Ol' Jimbo's? Gumbo. Gumbo. All right, one big order of gumbo. Order number 2 is going to be a coffee this is Bianco Beans latte. What do you want?
It's got to be, I guess, Bianco's white, so it's got to be like some sort of whitish coffee.
So it's like a flat white. Yeah, Bianco Beans flat white. And then number 3 is going to be Terrence's fries and pies. It's a combo order, fries and pies. So each of these things is going to take a little while. Gumbo, an order of gumbo takes, how long does it take? Like 20 minutes? So that's going to be like 2 seconds, right? Because I can't really make you all wait for 20 minutes for the gumbo to come out. Virtual gumbo. Bianco Beans flat white, we're going to say that this one's a little bit quicker. This is going to be like 500 milliseconds. And Terrence's fries and pies, these are good fries, these are good pies. Terrence's fries and pies are going to be let's say 5 seconds. Right? So we got 2,000, 500, and 5,000. And what I want to do is I want to have like my simulator where it'll say stuff like, welcome to Big Ol' Jimbo's. So it's going to say something like, welcome to Big Ol' Jimbo's. What can I get you? And then there'll be a little menu, and you'll be able to pick from the menu. Right, so I'll go 1 for gumbo, 2 for Bianco beans flat white, and 3 for Terrence's fries and pies. So does that concept make sense of like what I want to build? It's going to be very similar to what we've built already, but just kind of hacking some pieces together. Right. So I'm going to go ahead and make a new file. This one's going to be called jimbos.js. And I'll start off with the easiest bit, which is console.log. Welcome to Big Ol'. Whoops. I'm gonna do double ticks just so I can use single quotes in here. Welcome to Big Ol' Jimbo's. And then we're gonna say, what can I get you? What can I get you? Does Big Ol' Jimbo's have an emoji for a logo? Just do. This is a robot restaurant, so Big Ol' Jimbo's is going to be a robot. Welcome to Big Ol' Jimbo's. What can I get you? And now what I want to do is maybe print out a menu. So I could go and console log all my stuff. So we'll go console.log, maybe press 1 for gumbo, right? And press 2 for whatever. I could do that. What I'm going to do is I'm going to try and be a little clever here, and I'm going to make myself an array of maybe menu items, right? Because I want to be able to add things to my menu in the future, so I don't want to like necessarily hard code too much stuff. I want to keep this sort of dynamic. And each menu item, what do you think I should put in here? How should I structure my menu items? So I might say some stuff like drinks, appetizers, and entrees. So inside of the menu items itself, if this is an array, what am I going to use to do that? An object, right? So I'm likely going to have an object. And in my object, I might do things like, OK, what is the type of the menu item? Maybe it's a drink, right? I'm going to ignore type right now because there's only really 2 things that I care about at the moment. The 2 things that I care about are the price. Sorry, not the price. The key that you press and the time that it takes. Right? Those are really the only 2 that I care. So this is going to be maybe something like an ID. Right? And then the other one is maybe going to be something like time. Right? Something like that. So I might say that maybe the ID number 1, right? Or yeah, the ID number 1, and then my time is going to be what did I say? It was 2,000, 500, and 5,000. So 2,000, and then I also need maybe the name of the menu item here. And this one was the gumbo. Right? And what I would like to have is maybe for const item of menu items, right? Maybe I want to press something like, or print something like, press, and then the ID. So something like press item.id for, and then the item.name. Right? I might do something like that. So now when I run this node at Jimbo's, I got press 1 for gumbo. Notice there's a billion different ways I could structure this. And honestly, one of the things that I'm probably going to find is that as I'm working on this, I'll have structured it slightly wrong. Not wrong, but slightly inconveniently. Right? And so my intuition was that maybe I should do this as an array of objects. I might find out in the future that it might have been better to do an object of nested objects, right? Or an array of arrays or something like that. Like I will just find out. And that's just something I'm going to have to live with and probably refactor later. Yep. So I want to add some more menu items. The menu items were, so this one's going to be 2 for the Bianco beans flat white, and that one was 500 milliseconds. And then there was Terrence's fries and pies, and that's number 3 for 5 seconds. And I can test this out and see, cool, I got 1 for gumbo, 2 for Bianco beans flat white, and 3 for Terrence's fries and pies. Now, what I want to do after I've printed out the menu is wait for an input. I want to wait for an input. And I already have that code over in keypress.js. Right? I already had something that essentially waits for input and then does stuff. So here's what I'm going to do. Copy and paste. Whoops. Paste. And I'll just get rid of some stuff. For example, you can never leave this restaurant. I'll let you leave the restaurant. But I'll get rid of some things in here. Like, I don't need my restaurant to go, ouch. I don't need these comments, so I'm just going to get rid of the comments. And to be honest, I feel like this kind of thing here, I want to do way up at the top, because this feels like configuration code. Again, maybe I don't understand what this code does, but most of the time when you're configuring stuff, you do it up at the top of your file. Right? So I'll take these 3 lines, and I'll just move them way up to the top. Right? That stuff. The nice thing about that is because I don't understand the code above. And I could just scroll past it and pretend it wasn't there. So I've got this thing that prints out the menu. I've got this thing that takes in an action. And what I want to do is console.log the data that comes through, maybe, and just see that, cool, it's waiting. And every time I press a key, it prints out the key I pressed. Now, I'm going to set a bit of a goal for myself. What I'm going to do is I'm going to say that when I press the key, what I want it to do is either print out the name of the item that I'm ordering, or if I pressed a key that doesn't relate to an item, I want it to print something like, please try again. Right? Just those 2 things. So the action is going to have to get a little bit more complicated. Right? Because I said, OK, here's the thing for checking to see if I quit. But then I'm also going to say, if the data is a valid order, right, then print the name. I'm probably going to need some kind of if statement there. Else, tell the person to try again. So some if-else situation is going to happen here. Right? Now, yeah?
Does JavaScript not have an
Easy input function? Oh, you mean like
C++
a...
or doesn't have something like
No. So the question here for Victoria was, does JavaScript not have an easy input function? Unfortunately, no. Like, you're going to find JavaScript, like Node is a little frustrating on input. Or at least Node is. There's going to be other stuff that you can kind of do to make it maybe a bit simpler. But built into Node, getting input is a little annoying, because you have to use this like on data. You're going to find that as you work with other languages, such as Ruby, at the end of the bootcamp, so you don't need to understand the code that I'm writing right now, but there is a function called gets in Ruby, and when you go gets, then it just waits for you to write stuff, and then it saves it. Right? So in Ruby, input is super easy. You just go gets. Right? So if I wanted to, I would go name equals gets. And I go Nima Boscarino. And now name is Nima Boscarino. Right? Ruby, very convenient. If only you were working with Ruby right now, which you're not. So unfortunately, with Node, we're going to have to deal with attaching listeners. What I want to see is this data in here? Is it one of the IDs? What do I do? Yeah? I did. So I did the if statement. Cool. So this is an array of objects. So how do I find the particular object that I want in here? I might have to loop, right? I might have to loop. So I might, writing a loop inside of the condition here is a little awkward. So I might do that just beforehand. I might do something like let found item. And I haven't found an item yet, so maybe I'll start off as null because I haven't found it yet. And then I might actually write a for loop that goes for, and then if I'm for over an array, then I can do a for of, or menu item of menu items. And then in here I might say if the menu item dot ID is equal to the data, then found item equals the menu item. Conceptually, does this make sense? You see how much work I'm putting into this, though? This doesn't feel like the right solution. Or rather, like it'll work. But what I'm feeling here is a little bit of pain from the way that I designed my menu in the first place. Right? If I had made my menu an object, right? So let me just remake the menu real quick. Whoops. If I had made my menu instead of an array, rather an object where it goes, okay, here's one. One has the name Gumbo and the time 2000, right? And then I do the same thing for 2 and 3. So this was Bianco beans flat white, which was 500, and then this one was Terrence's. Wait, I spelled Terrence's name wrong so many times. It's 2 R's. Terrence's pies and fries. Right? And this one was 5 seconds. What I notice about the way that I've structured this now is that as an object, I don't need to loop. I can just say, get me the one with this particular ID. Right? See, they're both solutions to the same problem. They're both fine. Right? We'll find that one's going to be a bit more awkward than the other. The reason I'm pointing this out is it doesn't necessarily relate to async. Right? And again, I don't want you to think of each lecture as being about one single thing. Right? But more along the lines of like, sometimes when you're working on a project, you get a little like tunnel vision in and a little stuck on like, oh, I need to pick the right answer, or like, oh, this, and I'd find that like I would just get very stuck, right? And the thing that I found that I did that made me a better programmer, really got the momentum rolling, was to just make decisions and just kind of deal with the issues as they came up, right? So here I ended up making a decision about an array, and then I find out later, array was probably not the best choice. It's OK, I'll just change it up. Right? It's very hard for you to make choices about stuff, like educated choices, without having the full picture. Right? That's just impossible. And you build up this full picture over time. So don't expect yourself to always know exactly what you're supposed to do. Right? So I'm going to change out my menu items so they're not this array anymore. Right? Instead, I'm going to keep it as an object. Because then what I get to do is, instead of having to do this whole loop, right, what can I do to get the particular menu item using the data that came in?
Did you say that again?
So if I want to, using the data that came in, get the particular menu item, what's that? So I no longer need to loop because I'm dealing with an object, right? If the data that comes in, so we'll just console log the data right now. So here's the data that's coming in. Oops. Oh, looks like when I did that, I ended up breaking up something else. My menu items, I can't for, what's that? Yeah. Sweet, if menu item data. That's exactly it, Victoria. I'm going to do that in a second, but I'm just going to fix this for loop. This is now going to be in, because menu items is an array, and I'm going to have to do something like item equals menu items key. Sorry, object. I just got myself backwards. It used to be an array. I switched it into an object, so I have to do as a for in. So just to make sure that works right now, that's fine. Press undefined for Gumbo. That's OK. We'll figure that out. That's going to be press the key for item name. Cool. And then just like Victoria said over there, Graham said that I can now go menu items data, right? Because I have some data, and then I also have menu items data. Right, we're going to see what the data is. When I press 1, that's my data, and that's my menu items data. Right? 5, that's my data, and that happens to be my menu items data. There isn't any. Right? So I'm going to write some code here that says, OK, when I have an item, then here I'm going to make item. Right? And my make item, this is going to be something like a set timeout. Something like a set timeout where I'm going to say, take however long you need, meaning menu items, data, dot, and then time. So wait for that amount of time. And then print out, a fresh, and then I'm going to say menu items data name. All right, so we're waiting however long we need, and then we'll go, a fresh Gumbo. A fresh Terrence's fries and pies. Otherwise, I'll console.log try again. And what we'll see now is that when I run this, I have this menu, and it says 1 for Gumbo, 2, 3. And when I go 1, after a little while, it should say, a fresh Gumbo. And I do maybe, I did a bunch of them, and now there's all these menus kind of happening in the background. And just to clean this up, I'm going to get rid of the useless console logs, like this one here that I don't need. This one here that was for debugging purposes, I'm just going to comment out in case you want to bring it back in later to examine. And then the last thing that I'm going to do just to get this to look nice is this for loop. I'm going to make a function called print menu, and I'm going to make this happen with a function so that it'll say, print the menu when the thing starts, but then also at the end of each one of these, print the menu. So every time you press a key, it'll order, and then it'll print the menu out again. And when I test this out, got no Jimbo, and it says, welcome to Jimbo's, what can I get you? I'll do a Gumbo. And then the menu pops up again. And the reason for this is because if I do a bunch of these, after a little while, this clears out. So I got Terrence's fries and pies. And maybe there's just so many items that I just want to see the menu again, or something like that. Right? Or I might even do if data equals m, then maybe do print the menu. So now when I run this, I can order all the things I want. And then whenever I want to see the menu again, I go M. M. There isn't an order that matches M, so right now it says try again as well. Right? So we covered a lot of things today. Right? This was the last thing that I wanted to show you. And these are all kind of sort of contrived examples of dealing with async stuff. Right? This final kind of stuff that I was doing, there's a lot of code in here. Right? I don't expect you to come out of this lecture fully understanding this stuff. What I expect you coming out of this lecture with is the idea that when we're dealing with async stuff, it'll involve callbacks. Right? That's the main thing, is that when an operation takes a long time and we don't want to wait for it, we have to give it a callback so that it can run it later. That's the main thing that I want you to take out of this lecture, right? And it's something that I've been doing this whole time, which is, for example, with the set timeout, I'm not going to do this right now. I'm going to do this after a set amount of time. So here's this action. With the standard in on data, I'm not doing this right now. I'm doing this later. So here's an action to do. Right? And just that pattern. It's always going to look sort of different in different cases, right? But I want you to like try and identify when that pattern is rising up. Right? Does that sound good? Cool. You're going to be exploring async stuff in more tangible ways over the course of the week and also through the assignments that you're doing. I just didn't want to repeat your assignments. But most of the time, just to highlight this, and this will be in the notes, async stuff pops up whenever you're doing an operation that takes time. Operations that take time are usually things like writing to the file system, right? Making network requests, and trying to talk to a database. Things that aren't in your immediate control that need to be handed off to someone else, right? That kind of stuff is generally going to be async, and it'll just pop up. Cool? Are there any questions? Neato. All right. Well, then that is the end of this lecture. Hope you had a good time. Oh, thanks for the clapping, Anthony. Yeah. Oh, so sweet. That was so nice. No standing ovation. I get it. Fine. Encore. Let's do it again. No. So it is 12:06. I'll let you go. Have a great rest of the day. Enjoy the assignments. And if you do run into any issues or if you just have any extra questions, Victoria, feel free to Slack me. Vancouver as well. Feel free to Slack me, or like I'm always at my desk. You can swing by. Cool. Take care.